So today we're going to be talking about the period of sine and cosine functions. Okay, so yesterday we talked about the um, vertical stretch and compression, but today we're going to be talking about the horizontal stretch and compression. Okay, so yesterday when we talked about vertical stretch and compression, we talked about amplitude. Today we're going to talk about period, which is just a fancy way of saying a horizontal stretch or compression. So we're using the same letters we did with polynomials with a, b, h, and k, but this time b is a positive number, and the period of a trig function sine or cosine is given by the period being equal to 2 pi over b, because 2 pi is the normal length of the sine or cosine curve, one period of it. And then we're going to use b to find our new period, or how long the new wave is. Okay, so we have a horizontal stretch if my b is between 0 and 1, because that'll cause my period to be greater than 2 pi. It's a horizontal compression if b is greater than 1, because when we plug it into our period equation, the period will be less than 2 pi. So obviously if the length is less than 2 pi, it's been shrunk or compressed, and if it's greater than 2 pi, it's original, then it has been stretched. Okay, so the easiest way of doing this is to graph it. Okay, so I've got my y-axis is going to be right here. So this is the y-axis, and this is 1, and this is -1, and this is my x-axis, 0, and I'm going to count off every 3 will be pi over 2, 2, 3, 1, 2, 3, 2, 3. Okay, and each one of these will be pi over 2. So that's pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, this is 5 pi over 2, 3 pi, 7 pi over 2, and this is 4 pi. Okay, so we always start by drawing our parent function, and since we're dealing with cosine, our parent function is cosine x, which starts here at 0, 1, pi over 2, 0, pi -1, like that. So here is my parent function for my cosine wave, like that. Okay? So here we go. I'm going to start by graphing this transformation, since we're sketching cosine of x over 2 and cosine of 2x. Thinking back to original transformations and what it says right up here, if b is greater than 1, then it is a horizontal compression. Okay, so in this case, b is 2. So we're compressing it. So basically, we're cutting all of my x values in half. That's what a horizontal compression does. So this coordinate, 0, 1, it cuts the x part in half. So 0 times 1/2 is still 0. This one here, pi over 2, cut in half, ends up being pi over 4. Pi cut in half would be pi over 2. So this one's shrunk to there. That one's right there. 3 pi over 2 divided by 2 is 3 pi over 4, which is right there. And, sorry, this should be at 2 pi. I made that. This should be here at 2 pi. Missed that one. And then that one, of course, will be shrunk down to pi. So this will be compressed to here. So my full cosine wave only reaches pi instead of going all the way to 2 pi. So you can see, since I cut my x's in half, my cosine wave is half as big. It only goes to pi. Okay, that one's relatively easy. So let's look at this one right here. Now this one's a little more difficult to see because b isn't sitting right in front of it, but you should know that dividing by a number is the same thing as multiplying by its reciprocal. So dividing by 2 is the same thing as saying 1/2 times x. So in this case, my b is 1/2. So since b is between 0 and 1, this is a horizontal stretch, and what it's going to do is multiply all my x values by 2. So just like we did for the compression, we're going to look at our parent function and actually multiply them by 2. So for instance, the x value here is 0. 0 times 2 is still 0. This is pi over 2 times 2, which will be stretched out to pi. Pi times 2 gets stretched out to 2 pi. Now notice it's still the same y value. So the y value here is 1, it's still 1, but the x value is stretched to 2 pi. Then 3 pi over 2 times 2 gets stretched all the way to 3 pi. And 2 pi multiplied by 2 gets all the way out here to 4 pi. So connect our dots. And there is our cosine wave. That is cosine of x over 2. So this is basically the same thing as we were doing at the beginning of the year with transformations, but now we're doing it with trig functions. Now, going back to what we started with the equation for period, let's look at that. So period is 2 pi over b. And for my cosine of 2x, b is 2. And of course, we plug in b, and we get pi. So my period is pi. So what the period basically is telling us is how long this cosine wave is. One full wave takes only 2 pi. That's why it stops right here at pi. Same thing with the blue one. If we use the equation, p equals 2 pi over b, which is 2 pi over 1/2, which ends up being 4 pi. And again, my new length for that one is from 0 to 4 pi. Now, the other thing is that this b in science, when we look at it, this b right here is also what we call frequency. B is what we call frequency because it tells us how many times we're going to see a wave. And in this case, when we talk about the original period being 2 pi, the frequency will tell me how many times we see it between 0 and 2 pi. So for instance, if I continued on with this red one, basically you'd see this one comes down here. If I graph another one, it looks like this. So if it kept going, it would get to 2 pi there. And how many cosine waves do you see? You see 2 because the frequency is 2. With the blue one, the frequency is 1/2. That's why when you get to 2 pi right here, you only see half of our giant cosine wave. It's the frequency. Okay? So very often science and mathematics use very similar ideas, but we kind of call them different things. So that'll kind of help you, because especially if you see cosine of 3x, you know, oh, the frequency is 3 in 0 to 2 pi, which means that is obviously to get 3 in there, you've got to compress it. Okay? It makes more sense when you think of it in that way. Okay? So we've got some practice problems just finding period and amplitude. Okay? So for this first one, we're going to be using the idea of this equation. Okay? A F B x minus h plus k. Okay, these are my transformations, basic transformations for any function. A is the one that's out front, and B is the one that's multiplying by x. So for my period, I need to know what B is. Well, what's B here? And my equation is 2 pi over B. Well, there's that 1 right in front. So this is 2 pi over 1, which is 2 pi. So the period here is 2 pi. The amplitude comes from this number multiplied in front of the cosine. So the amplitude here is 5, because A for amplitude. Okay? That easy. This is what we're talking about doing. Okay? So for the second one, again, we can rewrite this as 1/2 x inside so that we can find what our B is. So again, period is 2 pi over B, which is 1/2. So the period is 4 pi. So the period here is 4 pi. And my amplitude is the number in front of sine, which was going to be 1. All right, so for the third one, we need my period. So it is 2 pi over b, and in this case, b is 4. And 2 pi over 4 reduces down to pi over 2. So my new period is pi over 2. So this is a compression. And the amplitude is 1/3. There you go. All right. The next one. So this is my b. So again, using that same equation, 2 pi over b in this case, which is 2/5. And dividing by something is the same thing as multiplying by its reciprocal. So 2 pi times 5, that's 10 pi over 2, which is 5 pi. So my new period is 5 pi. The amplitude is a, that's the 3 in front, and my amplitude is positive 3. You need to be very careful on problems like this, because the amplitude is the number. This negative right here, the negative sign, is actually another transformation. That's actually a reflection. That's a vertical reflection. The amplitude is a distance, so it should always be the absolute value of whatever this number is. So that's a common mistake that people make, and they'll tell me the amplitude is negative 3. The amplitude is 3. The negative is just telling me that there's been a reflection in my function. All right, the last one. So again, this right here is b, but again, like the last problem, we don't use the negative. The negative is a reflection as well, so we put 3. So this is 2 pi over 3. So 2 pi over 3 is my period. And my amplitude comes from what's out in front, and that is x. Now, the reason I gave you secant is because it doesn't matter. I know that you haven't learned possibly the secant's parent function, but it doesn't matter. It doesn't matter what your parent function is. The transformations are the transformations. So it doesn't matter that I put secant there or x. X is a number. You just don't know what it is yet. So x is the amplitude. So based on what we put in, our amplitude is going to change. Okay? But that's all there is to it. You just need to make sure that you know the transformations, and then you can apply them to any of our functions.